Hello everyone, welcome to our mathematics channel 360 degree mathematics. Today we will discuss theory of quadratic equation. In the past videos we discussed different types of progressions, that is AP, GP and HP. And in this video we will start theory of quadratic equation. What is the concept of theory of quadratic equation? The equation of which unknown variable has two values is simply called quadratic equation. The form of quadratic equation is ax square plus bx plus c equals to 0, where a equals to constant coefficient of x square, b equals to constant coefficient of x, and c is the pure constant term. Here a not equal to 0, while b and c may be 0. If a becomes 0, then it is not quadratic equation because ax square will be vanished. Now a not equal to 0 is the prime conception here. The values of x which satisfy the equation are called the roots of the quadratic equation. Suppose we solve this type of quadratic equation and we get the different values of x, and these values are the roots of the quadratic equation. There are two theorems regarding quadratic equation. Theorem number 1, if alpha be a root of the quadratic equation ax square plus bx plus c equals to 0, then x minus alpha is a factor of the expression ax square plus bx plus c. Conversely, if x minus alpha is a factor of ax square plus bx plus c, then alpha is a root of the equation ax square plus bx plus c equal to 0. Now the theorem 2, a quadratic equation has two and only two roots. This is the proof. We consider the general form of quadratic equation ax square plus bx plus c equals to 0. Now ax square plus bx plus c equals to 0, taking a common from whole structure, we get x square plus b by ax plus c by a equals to 0. Since a not equal to 0, therefore x square plus b by ax plus c by a equals to 0, and hence make it square form x square plus 2x into b by 2a, that is 2 cancel, that is bx, x square plus 2x into b by 2a plus b by 2a whole square plus c by a minus b by 2a whole square. This is extra term and this will be cancelled. This x plus b by 2a whole square plus c by a minus b square by 4a square equals to 0, and by calculation we get x plus b by 2a equals to plus minus root over b square minus 4ac by 2a, that is x has the value minus b by 2a plus minus root over b square minus 4ac by 2a, taking LCM 2a minus b plus minus root over b square minus 4ac whole divided by 2a. Now x has two values, one is called alpha and another is called beta. Then we get alpha equals to minus b plus root over b square minus 4ac by 2a, beta equals to minus b minus root over b square minus 4ac by 2a. Therefore we can say that a quadratic equation has two and only two roots. Now we will mention fundamental theorem of algebra regarding quadratic equation. The statement is that every algebraic equation with real or and imaginary coefficient has at least one root, real or imaginary. Now we get relationship between roots and coefficients of a quadratic equation. Sum of the roots alpha plus beta equals to minus b by a, that is equals to minus coefficient of x by coefficient of x square, and product of the roots alpha into beta equal to c by a, that is constant term by coefficient of x square. Now we will discuss roots are given and equation is to be formed. Alpha and beta are given as two roots, then required quadratic equation is x square minus sum of the roots into x plus product of the roots equal to 0. Now we present two examples for the for the given structure, form the quadratic equation with the roots 3 plus root 2 and 3 minus root 2. These are two roots. Given the roots 3 plus root 2 and 3 minus root 2. Now sum of the roots 3 plus root 2 plus 3 minus root 2 equal to 6. And product of the roots 3 plus root 2 into 3 minus root 2 equals to 3 square minus root 2 square. That is 9 minus 2, that is 7. Required quadratic equation is x square minus SR x plus PR equal to 0, and this becomes x square minus 6x plus 7 equals to 0. Now the second example is that form the quadratic equation with the roots 1 plus I and 1 minus I. These two roots are imaginary and conjugate complex. These are two conjugate complex. Given the roots 1 plus I and 1 minus I, sum of the roots 1 plus I plus 1 minus I equals to 2, and product of the roots 1 plus I into 1 minus I equals to 1 square minus I square equals to 1 plus 1 2. The required quadratic equation x square minus SR x plus PR equals to 0, that is x square minus 2x plus 2 equal to 0. These are the two examples. This is all about today, and please keep watching our channel for the rest part of the quadratic equation. Thank you all for watching this video.